Hello everyone. Once again, welcome back to the sessions on the advanced communication. This is the session 4. The content we are going to cover in this particular session are modulator, line type modulator, duplexer, and in that is the branch type of the duplexer. That is, in this particular session we are learning about the what is the modulator circuit here, and in that the one type of the modulator is the line type modulator here, and also what is the duplexer circuit. Among that, again, one type of the duplexer is the branch type of duplexer here. Therefore, all these topics we are going to cover in this particular session here. Now, modulator. In the last classes, we have studied about the pulse type of the radar. That is, in case of the, again, in the radar classifications, we are having the mainly two types here. That is the continuous wave radar and the pulse type of the radar. Depending on the type of the waveform, we are editing there. Which type of the signal we are editing, depending on that, either it is the continuous or the pulse type. Again, in case of the pulse type radar, the signals which we are transmitting, those are in the form of the pulses there. Therefore, the signals should be in the form of the pulses. To make that controlling, that is to make the transmitter section on and off. To make the transmitter section on and off, the circuit which we are using is called as the modulator here. Therefore, the main function of the modulator is to turn the transmitting tube on and off to generate the desired waveform or to generate the desired pulses here. Therefore, this is the practically the modulators which they are using in the application here in the radar. You can see here, and this is also one of the modulator here, such that it will turn on and off the transmitter section here. Now, the basic principal diagram for the modulator is here. If you observe here, it consisting of the main energy source here. This is the main energy source, and here we are having the energy storage element. Usually, the transmission line type of the combination of the inductor and the capacitor, those they will use here. And here we are having the charging impedance, and this is the load where we are connected. For example, this is the transmitter section here. This is the load here. Now, if you observe here, here we are having the switch here. Here we are having the switch, and here the outer dotted path here. Outer dotted path that indicates the charging path here. That is, that indicates the charging path, and inner dotted path indicates the discharge path here. Actually, this inner dotted path indicates the discharge path, and this is the outer dotted path indicates the charging path here. Now, here in this particular modulator circuit, the energy storage element is continuously stores the energy from the external energy source here. That is, from the external energy source, the energy is transferred to the energy storage element through the charging impedance. Through this path, the energy is transferring from this external energy source towards this energy storage element here. Means it is storing the energy, and the purpose of the charging impedance is to it will controls the charging period here, at what rate the energy storage will takes place, whether it should be very fast rate or very slow rate here. Therefore, that charging period or that intensity of the charging period, that is controlled by this charging impedance here. Now, this is storing the energy. Now, during the off period of the pulses here, because we are having, as you know, we are having the on and off periods here. Pulse waveform, if you consider here, suppose this is the pulse waveform here. Now, here during the off period, during this off period here, the particular charging of this external from this energy source to the energy storage element, it takes place here. During this period, off period, here the energy is storing, that is shown by this outer dotted line here. It is flowing here through this charging impedance. It is entering here, again it is coming back to this particular here. It is completing the path here. Now, consider once it is completely stored here, whenever we want to turn on the transmitter section, whenever we want to turn on the transmission section, at that time this switch S is closed. During the charging period here, this off period, the switch S is opened there. During that period, that is opened. Now, during this period here, it is closed. The switch is closed here during the on period here. Therefore, it is closed. Once the switch is closed, what will happen? Whatever the energy is stored here, it will start discharging through this load here. It will start discharging through this load, and that is indicated by this inner dotted path here. That is indicated by this inner dotted path. Now the main job of the charging impedance during this discharge path is such that it will take care that the reverse energy flow is stopped here. It will take care that the energy should not transfer again from this energy storage element towards the energy source. This reverse path, whatever the reverse path is there, that is stopped by this charging impedance. Therefore, the energy will completely flow through the inner circuit, that is this energy storage element, load, and this switch here. Through this switch again, the path will be complete here. This inner dotted line, that is completes discharging. Therefore, that is the on period here. Again, during the off period, what will happen? The switch is opened here. Again, they will make the switch as open. Again, the energy will start storing towards the storage, this energy storage element here. Now, this is the basic principle or the working here. Now, how this particular line type of the modulator, this is called as the line type of the modulator circuit here. How this will works here. That is, if you consider the line type of the modulator circuit, it is having the energy source, charging impedance, energy storage element, load, and this is the discharge path and the charging path here. Now, this is the switch here. Now, let us move on to the next, this one. This is the one of the example, whatever the principle you have learnt, same is applied here. That is the line type of the modulator. Their energy storage element here used is the, that is, this is the energy storage element. That is the part of the transmission line. We are having the inductor and the capacitor combinations here. The inductor is having the tappings here. Therefore, depending on the values, that can be adjusted here. We are having the inductor and the capacitor combinations that charging, and through this external energy source, this is the impedance here. From that external energy source, here it is charged here during the off period of the pulse, and during the on period here, that particular energy is discharged here. Same principle. When the switch is open here, this switch is open, this particular storage element will store the energy. It will store the energy from the external source here, from this here. And when this switch will be closed here, this will start discharging through the load here. This will start discharging through the load here. This is the working of the line type of the modulator circuit. Now, moving on to the next circuit, that is the duplexer circuit. Already this also, we have come to the word duplexer in the basic block diagram of the radar here. Yes, what is the duplexer? As we know, if we are using the same antenna for the transmission and the reception purpose, if we are using the same antenna, then to protect the sensitive receiver from the high voltages or the high power of the transmitter section, we are using the circuit called as the duplexer. That is, duplexer will take care that during the transmission process, the receiver is temporarily disconnected, and during the receiving process, all the energy echo signal will be submitted to the receiver section, not to the transmitter section here. Therefore, that is the one of the main task of the duplexer here. Now we will study one of the example for the duplexer. Now, duplexer, what is the duplexer here? It is an electronic device that allows bidirectional communication for the simple path here. That is, bidirectional communication means it is communicating to the transmitter as well as the receiver path here over the single path. Now, in radar and radio communication systems, it isolates the receiver from the transmitter while permitting them to share a common antenna. Means it is isolating the receiver section. It is protecting the receiver section because they are using the common antenna here. If you observe here, they are using the common antenna. Therefore, to protect the receiver section, they are making use of this duplexer circuit here. Now, most radio repeater system include a duplexer. Most of the radio communication, the repeater blocks will be there, no? Because those repeater blocks, they are using the common antenna for transmission as well as the receiving purpose. Therefore, they will include the duplexer circuit. Now, if we just go through the basic diagram here, this is one of the duplexer, actually what they will use here. In reality, practically, the duplexer, the equipment here. Now, the diagram, if you consider, this is the antenna. Now, for example, this is the transmitter here. This is the transmitter section. And this is the receiver section. This is the receiver section here. Now, during the receiving time, the duplexer is connected to the antenna and it is going to the receiving here. Transmitter is disconnected here. And now during the transmission process, the receiver will be disconnected and this particular switch will be connected to the transmitter section here. Therefore, this is acting as the particular, this one, that is the transmitter and the receiver. It is connecting whenever the transmission process will be there, receiver will be disconnected, and whenever the receiving process will be there, transmission will be disconnected here. Therefore, we are using the same antenna for the transmission and the reception purpose. Even though we are using the same antenna, the duplexer circuit, it is protecting the receiver circuit here. Now, if you consider the blocks here, this is the transmitter, receiver, and it's the duplexer here, and this is the antenna section here. Now, red color indicates the transmitting signal here. It is going towards the antenna, and green color indicates the particular receiving signal here, which is coming to the receiver section here. Now, one of the type of the duplexer is the branch type of duplexer. This diagram is for the branch type of the duplexer here. Now, how it will works here? How it will works? If you consider here, this is the transmitter block and this is the receiver block here. This is the transmitter and this is the receiver here. Transmitter and the receiver. Now, this is the transmission line here. This is the transmission line. This is the antenna here. This is the antenna section. Antenna. Now, if you observe here, the receiver is not directly connected to the transmission line, but instead of this, in between we are having this one switch here that is called as the TR or the transmit receive switch. TR is nothing but the transmit receive switch here. Similarly, after the transmitter here, in between the transmitter and the antenna, we are having the one more switch that is called as the ATR switch. That is the anti-transmit receive switch here, ATR switch here. Now, these are the gas discharge type of the tubes here actually. These switches are nothing but the gas discharge type of the tubes here. Whenever the high energy will enters into these tubes, the gas will be ionized and they will act as the breakdown will take place and they will act as a short circuit. This portion will act as a short circuit when the particular energy will enters into these switches here. And when the particular energy is not there, if the energy is not supplied, after some time again they will return to their original position, that is the open here. Again, whenever there is no energy, they will be in the open condition only here. That is the main working of these two switches here. Transmit receive and anti-transmit receive switch. That is, these are the gas discharge type of the tubes here. Whenever the high energy will enters into these tubes, what will happen? During that time, the ionization of the gas will take place. The breakdown of that particular discharging will take place, and they will act as a short circuit here. Both will act as a short circuit. And when that particular high energy is removed here, again once again they will act as an open circuit here. Now consider here, if you observe here, the distance between the transmission line connection here, from here to here, we have taken the lambda by 4. That is a quarter wavelength transmission line length here. Quarter wavelength. And here also the length maintained is the quarter wavelength here. And one of the speciality of this quarter wavelength, this transmission line, if you consider, the length is exactly lambda by 4. For example, lambda by 4 length here. If the length is exactly lambda by 4, then what will happen here? If the one end is open, then automatically the other end will act as the short circuit here. Similarly, if the one more transmission line, if you consider here, again the length is lambda by 4 here. Again, if you take the one end is closed here, for example, this is closed means automatically it will act as the open to the other end here. This is the speciality of the lambda by 4 length transmission line. Therefore, for that purpose, they have taken this. Here also length is lambda by 4 and here also the length is lambda by 4. Now consider during the transmission process what will happen here. During the transmission process, the high energy is flowing here, correct? The high energy will be flowing here like this. Now it will enters here also, and it will enters here also, this high energy. Okay, now once this high energy is entering here, what will happen? This will be ionized and it will act as the short circuit here. This end will be short circuit. Similarly, when this high energy is entering here, this will be ionized and this will act as a short circuit here. This will be short circuit. Now here it is short circuit, means here it will be open according to this lambda by 4 length, because this length is lambda by 4 now. This is short, means this will be open here. Now again this is short, means this will be open here. Therefore these two are not shorted here. Therefore the whatever energy is there, that is freely flowing towards the antenna section here. That is freely flowing towards the antenna section. And here no energy is reaching the receiver because it is short circuit here. It is blocked completely. It is not able to pass through this particular path and it is unable to reach here. Therefore, during the transmission process, receiver is completely disconnected from the circuit. During the transmission process, receiver is completely disconnected from the circuit here, because the energy is coming here, it is short circuit. Energy is again coming here, ionized and short circuit. Therefore here it is short circuit, means here it is open. Here it is short circuit, means again here it is open. Here these two are not connected. These 2 points are not connected. Therefore the energy will flows continuously here. Now consider during the receiving time what will happen. During the receiving time, automatically after the transmission pulse is over, there is no energy in the TR and ATR switch here. If there is no energy in the TR and ATR switch, then what will happen? This will be open here. This point will be open here. There is no connection, short circuiting here. If this is open here, means here it will be short circuit, because the length is lambda by 4. Because here it is open, means here it is short circuit here. Now here also there is no energy, but here it is open, means here it won't be lambda by 4 short circuit, because now it is open, means here what will happen? This is not short circuited, means it will be like connected to this one here, like this it will be. Now the length is no longer lambda by 4 here, it is more than the lambda by 4 here, because it is open here. It is not short circuited, means now this full length will appear as the transmission line here. This full length will appear. Therefore it is not the particular lambda by 4 length here. Therefore it won't apply this particular open and short circuit rule here. Now it will be open only here. Now whatever the echo signal will comes here, whatever the echo signal, because it is short circuit here, now it is open here. Since it is short circuit, it will be open here because of this lambda by 4 length. Now whatever the signal, echo signal is entering here, now it will comes here. Now it will tries to enter here, but it is short circuit here. Therefore it will reflect here. It can't enter here. Now the echo signal will be entering to here. Now there is no short circuit here. Therefore freely it will enter through this switch here to the receiver section here. Therefore during the receiving time, the particular transmitter section is disconnected here. Only the signal is reaching towards the receiver block. Now this is the explanation for this. This is called as a branch type of duplexer here. That is the branch type of duplexer. Branch type of the duplexer here. Now usually in the examination they will ask, explain the working of the branch type of the duplexer. You should explain the transmission process as well as the receiving process here. Now here same again explanation here, that is the during the transmission process here, the particular, this is the transmitter and this is the receiver. Antenna is connected and this will be disconnected, and during the receiving process it will be disconnected and the signal will flows here. As the purple color or the pink color indicates the transmission signal and this green color indicates the receiving signal here. Whatever I explained same here. Now the same thing we can explain through this mind map here. Now see here, if you observe here, this is the antenna section, transmitter and the TR switch here. Okay, this is the TR switch, and here through this TR switch we have connected the receiver section here. Through this TR switch we have connected the receiver section. Again, transmitter section is connected through this ATR switch here. ATR switch here. When during the transmission process, what will happen? This will enters into TR switch as well as the signal will be entering. The red color line indicates it is entering into the TR switch also here. Therefore, both are ionized and they will act as the short circuit here. Now, whatever signal is there, that will enters into the antenna. That will enters into the antenna, because now it is also short circuit and here it is also short circuit. Receiver is disconnected here. Now during the receiving time, what will happen? These are not having any signal temporarily, then they will act as an open circuit here. Now these two are open circuit, means at the other end there will be short circuit here. Therefore, transmitter is disconnected. Now here from the receivers, from the antenna, the signal is directly going towards the TR switch and it is entering into the receiver section there. Therefore, the same branch type of the duplexer explanation using the mind map here. Now let us watch a small video that indicates how this duplexer is used to for the same antenna usage there. That is how it will help that in the case of the when we are using the same antenna for the transmitting and the receiving purpose here.
Now we need to know how a transmission and reception takes place in a radar. The block diagram of a simple radar system is shown. This block diagram indicates that the radar system consists of both the transmitting and receiving system. The transmitting system consists of a transmitter and a pulsar. The receiving system consists of a receiver and an indicator. In most cases, a single antenna is used for both transmission and reception, and this is achieved with the use of TR switch, that is, transmitter-receiver switch. This switching arrangement is called a duplexer. This connects the antenna to the transmitter during transmission and to the receiver during reception. Moreover, this switch isolates the sensitive receiver from the damaging effects of the high-power transmitter. The transmitter is essentially a high-power magnetron oscillator which generates high-power pulses. This transmitter is turned on and off with a periodic pulse from the pulsar. Thus, the transmitter generates periodic pulses of very short duration. These short pulses are fed to the antenna, which radiates them into the space. The antenna is highly directional. If the transmitted pulse hits any target, a weak echo signal returns to the same antenna. But now the TR switch puts the antenna in contact with the receiver. This echo signal is amplified and demodulated by the superhet receiver. The sensitivity of the receiver is very high. The detected output is sent to the indicator. The indicator is a cathode ray tube. The CRT, that is, the cathode ray tube, displays the original transmitted pulse as well as the detected echo pulse along a horizontal baseline. The synchronizing pulse generated by the timer is supplied to both transmitting and receiving systems. So, the indicator records the transmitted pulse as well as the returning pulse simultaneously. The returning echo pulse appears slightly displaced from the transmitted pulse, and this displacement is a measure of the range of the target.
Okay. In this particular session, we have learnt about what is the modulator, what is the line type of the modulator, and what is the duplexer, and what is the working of the branch type of the duplexer here. Thank you for watching, and in the next session, we will continue with the next topic here. Thank you.